It be the last experiment, lab number 10. Lab number 10. Okay. So, this is simple pendulum. So, we are going to measure from this the value of G experimentally. Okay. So, what we are going to do? We know that the formula for the simple pendulum is T equals to 2 pi square root L over G. Okay. So, this is the formula, T equals to 2 pi L over G. So, what is T squared is 4 pi squared L over G. So, from here T square equals to 4 pi square over G. So, this is constant and L is changing. So, you are going to change L and you will get. So, when you plot it L versus T square, you will get a straight line. So, the slope, and if you compare this equation with y equals to mx, so your slope will be 4 pi square g, and your g will nothing but 4 pi square divided by the slope. And how do you find the slope? You will find it from here. You select 2 points and slope will be y2 minus y1, x2 minus x1. Okay. So, this is how we get G, and from the experiment we get the G now. Okay. Can I have it? So, we are going to verify the simple pendulum. We have length over here given, which is we can measure the length from this center point to this center point, which is given like 34 centimeter, which is mentioned over here 0.34 meters, and we are going to deflect it less than 10 degree. Okay. And when I deflect it less than 10 degree, it oscillates. So, when it oscillates, I collect the data. So, I will get the data from here, okay, and automatically it will stop after 10 seconds. Okay. If it stop, then I zoom it, okay, and then because it is a sine curve, so I will select it and then make a curve fit. Which curve is this? Sine. So, where is sine? Cubic. Sine. Okay. So, sine, try fit and okay. So, what you get is B. So, your sine curve, which is a sine of omega t plus phi. So, your omega, so what you will getting over here in the lab fit, which is giving you a sine b t plus c plus d. So, your B is nothing but your angular frequency. So, B is angular frequency. Okay. So, the angular frequency we get 5.94. Okay. So, yeah. So, 5.494. Okay. This is your angular frequency. Now, how to find T? So, you will get B from here, which is this. So, calculator, where is the calculator? Okay. So, 2 pi divided by omega, which is 5.94. So, you will get 1.056, and now you are going to square it. So, you will get 1.115 or okay, and then then we are going to substitute in this value. So, you will get G in this formula, you will get G. Okay. So, this is the first, and then you will set experiment, store latest run. Then what you are going to do is to change the length. So, it was 34 first, and then you change it little bit 32. So, measure it from here till the center. So, it is not 32 yet. So, we are going to make it 32. Okay. So, we make it 32, and then what we are going to do? We make another run less than 10 degree, and when it is going, we are going to record it. Okay. So, like this, it is recording. Okay. It stopped. When it stopped, you make it a zoom it, okay, and then fit it with the latest run, okay, and then which curve? Sine curve, try to fit. So, you will get another B. So, what is another B? 5.630. Same you will get T squared, and then okay, and the same for the 30 degree, and then for 30 centimeter, and then 20 centimeter. Whatever you get over here, you have 4 values divided by 4, you will get the experimental value of G. Okay, and then you will plot this length and this T squared over here. So, when you plot over here, you will get TL over T square. So, you will get a straight line. Then you will get a slope, okay, and this will give you G equals to 4 pi square divided by slope. Okay. Then whatever you get from here, this is your experimental value, and this is your theoretical value. So, experimental value minus theoretical value divided by the theoretical value mod multiplied by 100 will give you the percentage. And in the last part, you will get the length of the pendulum, whatever the length is there. You write it the length. For example, in our case, this is 0.32 centimeters. Okay. So, you start it, you make it a very small angle like 5 degrees, okay, and do it, and then do the calculation, calculate the angular frequency and the time period, then make it a little bit 15 degree, and then make it, and then calculate, and then answer these 2 questions. Are the T depending upon the value of a large value? Write your answer, and what are the possible errors that can happen in this experiment. Okay, everything is clear? Okay.